So, following on from that, I'm going to talk a little bit more about the future, the more aspirational stuff, the H3. Although some of the things I'm going to talk about, they're already being delivered now. So this is more H3 for the built environment, which is, as we said already, slightly behind industry. So I'm going to start off with a discussion, short discussion on the Metaverse. It's the new buzzword that's hitting the streets. And it's also known as Web3, so these two are interchangeable, Web3 and the Metaverse. And the Metaverse is really all about a shared space to join companies and people with places and things. That's it. There are no more definitions, there are no more rules. So within there's a large scope for interpretation. There's a lot being talked about with Facebook and Meta and gaming industry. They are absolutely things that are going to go on in the Metaverse. But by far the bigger things are the business-to-business transactions. So to sort of bring that into line, and I know it's hard to see some of these words on the screen, I'm going to just talk about Web 2. Now, I don't know how many of you remember the tech stock crash, 2000, 2001. Huge crash. Everything went down. But the proposition that tech was behind didn't crash. It was only the overinflated expectations investors stopped investing, so the tech stocks went down. But quietly in the background over the following decade, everything changed. You know, Amazon arrived. It's far easier to buy from Amazon than it is to go into the town centre and buy from a shop. You've got a much wider choice, so people started using it, and it went from sort of nothing in '95 to it's, you know, the biggest place to go shopping these days. The same with the iPhone. The iPhone came on and completely changed the way that we interacted with photos. It wasn't the iPhone that changed it, it was actually Snapchat. The ability to post the photos and then Facebook to push them on and really change the way we interacted, become easier to do it with an iPhone or an Android than to take a normal camera, get them developed, push them back, scan them, push them on. That industry was completely destroyed, along with 26 other industries, just completely gone. And if you look at the stats, look at some of the reports that came out, over that decade, 50% of the Fortune 500, 250 of the world's largest companies disappeared. Not bought by other people, disappeared, no longer exist, because they didn't make the adaptation. So when we talk about Web3, Web3 is going to be as significant as that for businesses. Web 2 really addressed the business to consumer more than anything else. Web 3 will really address system to system and B2B. It will start to enable these transactions that are currently difficult and untrustworthy, where you've got a lot of manual checks on invoices and invoice matching and things like that, will start to go away. So within the next decade, you will start to see more new winners that don't exist today coming online, and lots of the big companies that are here today that don't adapt will disappear. They'll be replaced. So what's in sort of the Metaverse? You could say that the background is everything we've already been talking about, data. It's a key component. But you know, it's built on top of another key component, the internet. So these are all enablers for us. But what's coming that's different is the ability to interact with that data a lot better. So through some of the standards that are coming out, we'll be able to overcome problems. If you've ever been a developer and you know about developing for a web browser or developing for one of these, it's two completely separate code bases. And there are very many of these. They all need different code bases for an Android and all the different variants of an Android and for different variants of the smartphones and the different variants of the browsers. So there's a couple of standards that are coming out that are going to make interaction single code base, which will make a huge difference. So you can write an app that will work on a PC or on a mobile, and really, you don't have to maintain two sets of code bases. So in the technical background, that's going to make a big difference. From you, what it'll mean is that if you're out on site and you've got an iPad, you'll be able to interact with that without a problem. When you go back to the office and you've sat in front of a screen or multiple screens, you'll be able to interact with that. And you get a consistent experience of accessing the data that you need to do. And that includes going into VR and AR. There's a lot talked about that from a gaming point of view. The Metaverse isn't VR and AR, that's an interface into the Metaverse. You play on there. There are some very good use cases for VR from a training perspective and from a design perspective and an inspection perspective. Probably though the biggest single thing that's going to happen is blockchain. So we've heard of blockchain behind Bitcoin and crypto coins. That's just one use case of blockchain. Blockchain will make the huge difference of taking that data that we talked about in the CDEs and our requirements and bringing it out and being able to interact with it on a trustworthy basis and facilitate transactions. And that then facilitates these other things called smart contracts. And to give you an example of that, I'm just going to talk through a flow. So if we imagine that we've got all of our data in our plans and we've got our schedules, that's what we do today. But we will have algorithms to take out that data automatically, take those parameters out. Going back to this model-based design we were just talking about, taking out those parameters and those schedules of when we need those assets, when they need to arrive on site, and push them out on site, through a smart contract, out to buy those services. So automatically, this is what I want to buy, this is when I want it to happen. And then on the other end, they'll be receiving smart contracts that will go, oh, I can supply that stuff. And it will look at when you need it, what you need, and be able to automatically create proposals for you, send them back to your buying smart contract, so that you can then get a full list from the marketplace of what's going to happen, including the key parameters of what those assets must do and when you need them. That will then allow the smart contracts at the other side to evaluate all those responses and probably can't buy it all from one source. So be able to pick which ones you want. And it will do that by looking at various different things. So if sustainability is important to you, it can look at your supply chain. You'll have to supply that data. What carbon is it going to cost me to buy these things from you and make choices based on carbon and sustainability? But it'll also be able to look at reliability, because by the time this happens, lots and lots of supply chains will be online on the blockchain. And one of the things you can do with the blockchain is you can find out what's going on across all transactions. So you can start to look at how often did this supplier deliver to the schedule that they promised. So you get reliability indexes to drive up one of the things we all suffer from, which is delays. And then we're going on to the sort of last two bits on here, which are going to be, what do I next do with that? Once I've agreed those parameters in the smart contracts with you, what you can then do is take parameters from supply chain that, for instance, logistics. This has been delivered. I've got the evidence automatically. It's been delivered on site. I know what's been delivered. The QR codes have been scanned. We know it's there. We don't need to do an invoice inspection or invoice matching. It's there. We just pay it. And that's another thing that smart contracts enable you to do. So it's really allowing efficiency, evidence-based payments, for instance, without you having to do manual work on the top of it. What that also allows you to do is deal with unexpected things happening. So within your smart contracts, if you're smart, you should be having the point that you get delays on your side as well as on the supply side. So on site, I'm not making the progress I need. I don't need these three things tomorrow. I need them next week. So you've really got to be able to work with those sorts of things to change how you're doing it. So how does that tie back to BIM? So what BIM is doing is giving you that key information. But that key information, from your CDE, your good quality information out of your CDE, isn't sufficient. What you need is context. And the BIM system doesn't always have the context. And what I mean by context here is process. Understanding the process. Where are we? What is it we're doing? And this is where the digital twin starts to offer extra capabilities on top of you. And I'll show you how we do that in a second. So the digital twin, the key element of the digital twin will be to provide you with that context that you need to automate those smart contracts. So what is a digital twin? So just put simply, a digital twin is a model of your processes. Part of those processes is design. So if you model the design process, out of the design process you have a 3D design. You get the asset, the 3D asset. Then you move on to the build process where you construct it. At the end of that you get a 3D building from that 3D design. And at the end of that you move into your operational processes. So you don't model the asset, you model the processes. And the assets pop out for free. Once you've got those assets, you need to bring in the data that tell you how those assets are performing. This is the IoT question we were talking about. So giving you the data you need to move to one of the questions from this morning, predictive maintenance instead of break fix, or past planned maintenance. And then lastly, what you're doing is starting to present that data back in those interfaces that your field service engineers need, the people on site need, your purchasers need, your people who are evaluating, and the quality managers and those sorts of things. So you can give the data back from essentially a contextualized CDE that brings in more data than just the CDE, brings in the financial data and whatever else data you need to bring in there to support those processes. So you end up at the end of this process with a model, a digital model of your actual assets that are out there, whether they're buildings, they're railway systems, or whatever. You'll have that data so you can use it within your own end processes. But it's all based on first principles from your design cycle. Can you see that? There we go, yeah. So what are the building blocks? So we've still got the data, but the key thing for understanding processes is domain knowledge, where you're subject matter experts. They're the people we need to bring in the room when we're discussing requirements for operational and maintenance later on. Those subject matter experts are really essential, where you get the domain knowledge from. Then underneath that, you've got these two things that you might not have heard about before: graph databases and ontologies. If you are looking to build a digital twin, and the digital twin you're buying isn't based on those technologies, then don't buy it, because you can't map the complex relationships with a traditional database. So graph databases are really strong at mapping relationships, as many relationships as there are in the actual world. And ontologies are an abstraction layer that allow you to capture your domain knowledge from your subject matter experts and then reuse it on the data so you can understand the processes that are gone. I haven't got time to go into that, but if you come on to stand 6, I can talk more about that later on. So how long does it take? Actually, it's surprising. So this process where you're going out and you're capturing takes about 3 months to set up, to really understand the processes, about 3 months to understand any process. After that, to adapt that to a slight different variant of the new process takes almost no time, hours. So then you can start to build digital twins from your data automatically. So if you've done a digital twin of one of your buildings, you can do a digital twin of all of your buildings. So the key on the whole thing is repetition and how much it takes to repeat the processes. And that's why you want this domain knowledge, to be able to drive these processes. So I'm just going to take you through this one very quickly. So what type of digital twins are there? Okay. It starts at the bottom with components, and it ends at the top with networks of networks. So I've done digital twins, this full scope. So down at a component level, digital twins of pumps, they're very valid for people who make pumps. If you want to know about whether or not your pump's going to break, you need digital twins to bring it all together. How's it being used? What the measuring parameters? But that then gets assembled into a pump set, which gets assembled into, say, a disinfection process within a waterworks. Each of those can have a digital twin. And you should build on the sort of component knowledge upwards, so building from the base upwards. So eventually you get your full water system for the UK or Ireland, that you've got a digital twin of the whole water system. based on the different piping, the different pumps. You've got a digital twin of your whole transport system or your whole energy system. And once you got to that level, you can have what we call a national digital twin. And I've been working on a national digital twin in Sweden that's up and running right now. All of the train operators are using it. So all trains and all tracks and everything is up and running on digital twin at that scale, national scale, that will then expand out and do other use cases. And we're looking at moving that into different countries. But what you will see, and why there's a lot of confusion in the market, is because you get tactical digital twins. People who take a digital twin and just use it for the design process. We do that in Sweco. We make the digital twins ourselves for our own benefit. The client might not buy it from us, but it's what we use in our projects, using tools like Bentley and iTwin. We don't do construction, so we don't make those tactical digital twins ourselves, but the construction companies probably will. And then at the end, we'll end up with operations and maintenance. And where do they get their data from? They have to build it themselves. So the idea of my job at Sweco is to take a strategic approach, look at joining up these gaps between the phases and reusing the data, exactly what we've been talking about this morning, how to reuse that data. And again, the key there is repeatability. It should not cost the same to do the second digital twin as it did for the first. We're heading for a zero marginal cost. We don't want it to cost anything, is what we're actually aiming for. And we can go quite a long way to that already. In the operational phase, if you want to see a digital twin of the operations and maintenance phase, come on to stand 6. We've got a product there called Twinfinity, which is a Sweco product. You can see that demo on there. Value proposition, what do they do? The main use case is reality. There is nowhere else you can go and see all of the data all at once than a digital twin. And once you can see all of that data all at once in context, you can start to do interesting things. And I'll skip right to the last bit here. So digital twins are the enablers for Metaverse, in my opinion. And what we're doing here with BIM, the BIM coordinators are the enablers for digital twins. So on that point, I'll leave, and I'm going to invite Menno to come up. We'll take questions on digital twins once Menno's finished his presentation and what he's going to do.